Hi all, in this video we are going to see how to convert regular expression into deterministic finite automata. This step is essential to convert a high-level pattern description into an executable machine-level code. And this process mainly optimizes the pattern matching and allows the fast string processing during the process of lexical analysis in compiler. While converting regular expression into DFA, there are two ways. One is a direct method and another one is the indirect method. In indirect method, the regular expression will be converted into NFA will be converted to DFA. In direct method, we are converting directly regular expression into DFA. In this video, we are going to see the direct method of conversion. Basically, the DFA is the efficient model which will be used for pattern recognition task because the next state of the automata is completely determined from the current state and the input symbol at any given point. To convert the regular expression into DFA format, we have to follow the following procedures. First, to be converted with the augmented regular expression, syntax tree generation, and number the leaf nodes, find the nullable of each node, find the first position, then last position, then follow position, followed by construct the D state and the D transition, and finally draw the DFA. And to know about what is a nullable, so nullable is a subtree where the node n generates including a language and the empty string. And first position n, which will match the first symbol of the string generated by the subtree at the node n. Last position is the positions that match the last symbol of the string generated by the subtree at node n. Follow position represent the set of positions that can follow position I in the tree. So in step by step, we'll see how we calculate all these values from the syntax tree. And this is our given regular expression. And the first step, we need to convert this regular expression into an augmented regular expression. So to do the thing, we are just having A bar B star, then followed by a dot symbol, and then A followed by B, and then followed by B, then followed by the symbol hash. And this representation is called as augmented regular expression. And now we need to generate the syntax tree. To create the syntax tree from the augmented regular expression, first we start with the parenthesis. So the symbols from the parenthesis will be written first with the R symbol at the node. Then followed by the star symbol and the concatenation symbol, which should be concatenated with the node A, the symbol A. And then this is followed by again concatenation with the symbol A. Then again the concatenation with symbol B, and finally concatenation with the hash symbol. And after generating the syntax tree, we have to number only the leaf nodes. So here the leaf nodes are the symbols where we have to number 3, 4, 5 and 6. And after numbering, we have to compute the nullable node and first position and the last position for every node. And these are the rules. You have to note it down all the rules. If the leaf is labeled by an empty, that nullable position is true and the first position and the last position also empty. If the leaf is with the position I and its nullable is false and the first position is I and the last position is I. And these rules you have to remember in order to identify or compute the nullable first position and the last position. And this is our syntax tree generated with the label number in the leaf node. And after doing that, first we have to find out the nullable. And in order to find out the nullable, as you know, these are the leaf node. So a leaf at position I, so automatically, and this is F and this is F. And then you see here, if you have the node with two child C1 and C2 and the nullable of C1 or nullable of C2. So automatically the nullable value of this also F. Then for the symbol star. For the symbol star, if you have a single child, automatically the nullable is true. So here we are having a true. Then we have the dot operator, concatenation, and there you have to check with the two child. So already these childs are false because we know that a leaf node with position I automatically based on the rule it is false. So now one true, one false, and with the concatenation it is an AND operator, so automatically it will be false. So again this become false and this become false and this also become false. After finding the nullable, next we have to find the first position and the last position of every node. And you need to find the first position and the last position of the symbol A. And the first position represents, that is here you see here, the leaf with the position I. And here the first position of this A. Okay, that node A, that will be the same value. That is I and I. And so here the node number is 1. So I need to actually find out what is the first position of I. So the first position of I will be the node 1. So it becomes 1 and the last position also 1. Similarly for the node 2, it is again the node 2 itself, because this is working for the leaf nodes. So here also it is 3 and this is 3. The first position is 4. The node number is 4. The I represent the node number. So here also it is 4. And the first position is 5 and the last position is 5. Here the first position is 6 and the last position is 6. So we have identified the first position and the last position of the leaf node. And now we have to find out what is the first and last position for the symbol R. And here the first position of C1 followed by the first position of C2. So I have to find out the first position of the symbol. So for that I need to find out the first position of this is C1 and this is C2. So the first position of C1, that is 1, union first position of C2, and that is 2. That is this thing, first position of C1 and C2. Similarly, I need to find out last position of slash. So that will be the last position of C1 and the last position of C2. So while I write the first position and the last position of the slash. Now I am going with the star symbol, and the star symbol, the first position of C1. So here I am having only one child. So for this first position of C1, first position of C1 is this. So I am having with 1, 2, followed by the last position of C1 and the last position also same thing, which will be taken from here. And now we finish this. Now we are going with the dot operator or the concatenation operation. And for this, we have to consider again, this is C1 and C2. And for this, if it is nullable of C1, I'm going to check whether it is nullable. Yes. Now, according to this, the child C1 is nullable. If the child C1 is nullable, I have to take the first position of C1 and the first position of C2. So, first position of C1 and first position of C2. So it becomes 1, 2, 3. Similarly, the last position, I am going to check the nullable of C2. But C2 is not nullable. So I am going to just go with the last position of C2, the else part. The last position of C2 is 3. And now moving to the next level, I am again checking the two child C1 and C2. For this particular node, the nullable of C1. Nullable of C1 is false, so it will go to the else part. The else part represents the first position of C1. So this is the first position of C1. So we are just writing the first position of C1. And what about C2? So C2 is also not nullable. So go to the else part, last position of C2. So last position of C2 is 4. Now repeat the same thing for the next level. This is again C1 and C2. C1 is not nullable. Go to the else part. Else part means first position of C1. First position of C1 is 1, 2, 3. And to find the last position, we are considering the C2. Nullable of C2 is again false. So go to the else part. So last position of the C2 is nothing but 5. So we are writing this. And this again you repeat for this. The child is not nullable. So else part. So first position of C1 and here the last position of C2. So now in this step we have find nullable for every node followed by the first position and the last position for the every node. And now this is the rule for computing the follow position. For every node, we have to consider whether the node is a concatenation node or the star node. For these two nodes alone, we have to find the follow position. And now we find the follow position of each node. As I already told, you need to consider only the concatenation node and the star node. So no need to consider with this or symbol. So to consider with the follow position, I'm just going to consider with ns star. That is this position. So when I take this position, I'm going to use this rule. I consider for each I in the last position. So what is the last position of the star? The last position of star is 1 and 2. So that I'm going to store it in the I variable. So I varies from 1 and 2. So I'm going to consider when I equal to 1. So when I equal to 1, then I'm going to take follow position of 1. Follow position of 1 is nothing but follow position of 1 union first position of n. So follow position of 1 is still I didn't find the follow position of 1. Then it is an empty. Okay. Then what is the first position of? First position of star. The first position of star, you need to consider here the first position of the star, which is 1, 2. So 1, 2. So the first position of 1 is 1, 2. So the follow position of 1 is 1, 2. And similarly, I am going to do for I equal to 2. I am going to take what is the follow position of 2. The follow position of 2 is nothing but follow position of 2 union first position of star. And again, you know that the follow position still for the node 2, I am not having anything. So it is an empty, which will be union with 1, 2. So the answer will be 1, 2. So the follow position of 2 is also 1, 2. Now we will move with the next node. So this node is now over. We are going to consider n is equal to dot. So when n is equal to dot, that is the concatenation, then we have to take every node from the last position of C1. So this only now I am going to take it. So this is C1 and C2. We are going to consider the last position of C1. So C1 is this, its last position is 1, 2. So I becomes again 1, 2. So we need to find out what is the follow position of 1. You know the rule already. Follow position of 1 union first position of C2. So follow position of 1 union first position of C2. So follow position of 1 already in the table, which is 1, 2 union first position of C2. This is C2, its first position. its first position is 3. So now it becomes 1, 2, 3. Similarly, I am going to do for follow position of 2. So follow position of 2, which is union with first position of C2. And follow position of 2, already from the table, it is 1, 2. Union, the first position is of C2. This is again same with 3. So your answer will be 1, 2 and 3. So now the follow position becomes 1, 2 and 3. And for the node 2 also the follow position become 1, 2, 3. Now moving to the next level, and this is now the next node we have to find out the follow position. So n is concatenation. So go with the same rule. Consider the last position of C1. So what is the last position of C1? The last position of C1 is 3. So last position is 3. So I is 3. So I need to find out what is the follow position of 3. So follow position of 3 is nothing but follow position of 3 union first position of C2. So what is a C2 here? This. Its first position is 4. So this is empty and this is 4. So your answer will be 4. Now moving to the next step, we are going to consider this node. Again, this is concatenation. Go with the same rule. Find the last position of C1. So last position of C1 is 4. So I is nothing but 4. We calculate what is the follow position of 4, which will be the follow position of 4 union first position of C2. So C2's first position is 5. So this is an empty union with 5. So the follow position of node 4 is 5. And now moving with the last step, taking the last node n is equal to star, we need to find out what is the last position of C1. Last position of C1 is again 5. So we find out what is the follow position of 5. That is nothing but follow position of 5 union first position of C2. What is C2 here? This is C2. Its first position is 6. So empty followed by 6. So your answer is 6. And for the node 6, the last node, we are not having any follow position. So that will be just an empty. So this is the thing we have created for every label. From this to this, we calculated what is the follow position for every leaf node. The next step is the construction of the D state and the D transition. And here we are having two symbols in the regular expression. We have to find the transition based on these two symbols. And these symbols are represented in the transition table. And we have to consider the initial state. The initial state is nothing but the node which having the information 1, 2, 3 and which will be considered as state A. And we need to find out which are the nodes are related with the symbol A. And here the node 1 and 3 is related with the symbol A. And out of this 1, 2, 3, which symbols are related with B? And here 2 is related with B. And from state A, based on the symbol A, how the transition will be happen? That will be formed by follow position of 1 union follow position of 3. So follow position of 1 is 1, 2, 3 and that will be union with 4 and 1, 2, 3, 4. And this is a new position, new state and which will be represented with B. And when from state A, based on the input symbol A, the state get transition from state A to state B. And similarly for state capital A based on the input symbol B. And for that we have only state 2, that is node 2. So follow position of 2. Follow position of 2 is 1, 2, 3, which already we have the symbol A. So now we have two states A and B. A represents node 1, 2, 3. B represents 1, 2, 3 and 4. And from the state A, based on the symbol A, you can move to the state B. And from the state A, based on the input symbol B, you can move to the state A. Now we draw the transition diagram. We have the start state A, and based on the symbol A, we are moving from state A to state B. And based on the symbol input B, we are moving to the same state. Now similarly, we need to find out the transition from the state B. And for that, we need to identify the symbols related with the state B. And out of 1, 2, 3, 4, A will be occurring in node 1 and 3. So you find out the union of the follow position of 1 and 3. That becomes 1, 2, 3, 4. And that will be again state B. And now consider the symbol small alphabet B that will be available in node 2 and node 4. Node 2, node 4. Taking the union of these two, we are getting 1, 2, 3 and 5. And this is a new state which will be named as C. So C, which having 1, 2, 3 and 5, and based on the B with the symbol input A, which will be moving to the same state. So write it here. And based on the symbol B, it will be moving to the state C. So we are considering state C. Now we repeat this for state C. Now we need to find the transition from state C based on the symbol input A. And out of 1, 2, 3 and 5, the symbol A appears in state 1 and 3. So follow of 1 and 3 union, we are having 1, 2, 3 and 4. And similarly the symbol B. So that will be occurred in node 2 and node 5. So now we take the union of these two, 1, 2, 3 and 6. So it becomes 1, 2, 3 and 6. So this will be a new state which is D, and this will be the same state B. So when the C comes with the input symbol A, it will move to the state B, and with the input symbol B, it will move to the state D. So the D you are having with 1, 2, 3 and 6. So based on the symbol A, it will be going to the state B, and based on the symbol B, it will be moving to state D. Now we need to find the transition from the state D based on the symbol A and B. And here we have 1, 2, 3 and 6 nodes, and we need to consider the symbol A. The union of this node 1 and 3 becomes 1, 2, 3, 4, which is nothing but state B. And based on the symbol B, it will be node 2 and node 6. Union of these two become 1, 2 and 3, which is nothing but state A. So it will be moving to state B and state A. Based on the symbol A, it will be moving to state B. Based on the symbol B, it will be moving to state A. And this is the final transition diagram, what you get from the regular expression. And since it is a final state, we just make it with the double circle to represent it is a final state. And this is the overview of what we have did. First, we have given with the regular expression and we have created an augmented regular expression, and followed by the augmented regular expression, we are just creating a syntax tree, and from the syntax tree we need to find out first the nullable and then first position and then last position. Then we have to find the follow positions, and using that we have to construct the D states and the D transition table, and based on that we have developed the final DFA diagram. I hope you have a clear understanding how to convert a regular expression to DFA using a direct method by using these procedures. Thank you.